Okay, so the question was asking us, what is the acceleration of gravity on the surface of Europa? Okay, well, if we said the mass of Europa is m2 and the radius of the Europa is r2, and we'll get the acceleration of gravity on Europa is g2 equal to g times m2 over r2 squared. Okay, g is the capital G here is the gravitational constant. Okay, and the the acceleration of gravity on Earth is given as g is equal to capital G times m over r squared. M is the mass of Earth, r is the radius of the Earth. And in the question, we're saying that the mass per unit volume is the same as Earth, which means the density of Europa and the density of Earth is the same. So rho Europa is equal to rho Earth, which will give us that m2, which is the mass of Europa, divided by the volume of Europa, which is, since the planet is a spherical type object, so the volume of it is just 4/3 times pi r2 cube. R2 is the radius of Europa, which is equal to m over 4/3 times pi r cube. Okay, and this will give us r2, the radius of Europa, is equal to r times let me see, was equal to r times m2 over m to the power of 1/3. Okay, and if we plug in back to the equation g2 equal to g times m2 over r2 squared, we'll get g2 is equal to g times m2 over r2 squared, so it's r squared, and then m2 over m times to the power of 2/3. Okay, and this will give us g times m2 over r squared, and then times m2 squared over m to the power of cube, so m cube. Okay, I'm sorry, no, this is, so this will give us r squared times m2 to the power of 2/3 over m to the power of 2/3. Okay, and this will give us, this is equal to g m2 to the power of 1/3 over r squared times m to the power of 2/3. Okay, and if we do some arrangement here, we'll get g times m to 1/3 over r squared times m over m 1/3, because m over m 1/3 is equal to m 2/3. Okay, and we can do some rearrangement here, which is g times m of r squared is equal to times m2 1/3 over m 1/3. We keep doing that, we'll get g times mr squared times m2 over m 1/3. Okay, so see, g times m of r squared is the acceleration of gravity, which is g. Let's mark it g. So this will equal to g times m2 over m to the power of 1/3. Okay, and we know the mass of the Europa, which is m2, is 4.9 times 10 to the power of 22 kilograms. And the mass of the Earth is about 5.98 times 10 to the power of 24 kilograms. So if we plug in, we also know that the acceleration of gravity is 9.8 meter per second square. So we'll get 9.8 meter per second square times 4.9 times 10 to the power of 22 kilograms over 5.98 times 10 to the power of 24 kilograms to the power of 1/3. Okay, and this will give us the acceleration of gravity on Europa. Europa is about 1.98 meter per second square. And this is the solution for the question. Thank you.